Hey, it's Alex Williams of the New Stack. Welcome to the New Stack Makers, a podcast where we talk about application development, deployment, and management at scale. We'd like to thank Aqua Security for sponsoring the New Stack's ebook about CICD and Kubernetes. You can learn more about Aqua Security at aquasec.com. Aqua Security helps enterprises secure containerized deployments through the entire life cycle, says Liz Rice. I sat down with Liz and discussed the context of security container technologies in CI/CD environments. Liz is a technology evangelist, and one of the things she says about continuous integration and continuous delivery is the importance of package vulnerability technology for customers to build into their CI/CD pipeline. Hey, it's Alex Williams of the New Stack here at KubeCon plus Cloud Native Con in Copenhagen. I'm here with Liz Rice, who this year is a co-chair of the CNCF. Congratulations, and you've done a magnificent job on stage, and I think bringing some great, focus. I really kind of feel a focus when you're up on stage talking about the project, so thank you for that.
Thank you very much.
Yeah, and so we're here to talk about continuous integration and continuous delivery in Kubernetes. That's the subject of our next ebook, and Aqua Security is a sponsor. And you work as an engineer there, and you are writing a little bit more about scanning. I've noticed this on the blog, right? This image of image vulnerability scanning, for example, right? Like you wrote about in December.
Sure.
We're hear more about kind of the CI/CD process in Kubernetes. I'm curious about your perspective from a security point of view. Perhaps you can start by just telling us a little bit about Aqua, who you are and what your kind of security context really is for Kubernetes.
Okay, sure. So Aqua Security helps enterprises secure their containerized deployment through the whole life cycle. So starting with those images and vulnerability scanning, which we'll talk about, and all the way through like runtime protection, secrets management. There's a whole lot of different aspects, network security. But if we're talking about the context of CI/CD, it's the vulnerability scanning and the image policies that are really the key parts to that process. And I've been writing about it quite a lot recently, mostly because I've been doing some work on a product called Microscanner, which is a free tool for developers to use, where they get to use our Aqua package vulnerability. It's the same kind of vulnerability intelligence that we use for our commercial product, but it's free for individual developers to use on their projects. Our enterprise customers will typically be building scanning into their CI/CD pipeline, and the product kind of hooks into your Jenkins or whatever your favorite CI/CD tooling is. Microscanner, on the other hand, is more of a standalone thing that you put in actually as a line into your Docker file. So it's an easy way for individuals. That might not really be the right approach for an enterprise to take, but for an individual developer to check their own images are not full of vulnerabilities in the packages, that it could be a useful tool.
Okay. So when we think about CI/CD and Kubernetes, is much different, right? It's a lot different approach, and Kubernetes is a much different architecture than people are accustomed to. The microservices are constantly, constantly crossing each other all the time.
Yeah.
How do you think about that? How do you think about that from a CI/CD perspective?
Yeah.
When you're thinking about an infrastructure that really is like a hive, really.
Yeah, I think it's a real concern for people who are coming into the Kubernetes space, into the orchestrated world, and traditionally they've run software on a machine, and they know where that machine is, you know, or even if they don't necessarily know, maybe it's in the public cloud, but they've got a name for that machine and they know what machine that software is running on. In the Kubernetes world, suddenly you're running these containers, these bits of software somewhere. You don't necessarily even know where. You've got these thousands of instances. And for a traditional, if you've come from a traditional security background, at first glance, this sounds really scary. And the reality is automation is your friend, right? Automation is in Kubernetes, deploying that software, deciding where to run that software. Automation as part of your CICD pipeline can help you secure it and make sure that you're only deploying images that you're confident in because they've been scanned, they pass your image policy. You might have rules around what levels of vulnerabilities you're prepared to accept, or who's built that image, maybe even some checking on the provenance of those images. There's all sorts of things that you can automate so that when Kubernetes does start running a container, running a pod with a container inside it, that container image you've got confidence in it.
Right. So you have the confidence and it's the trust that you're really trying to garner here.
Yeah, and the automation is key because the scale of these things, you couldn't possibly manually check all these different images when you're shipping, potentially hundreds or thousands of deploys in a day. That scale is beyond being able to do manually. But automation, CICD, is the key, hooking those security pieces into that process.
So we'll get to the security pieces in a minute, but question that I have is about when you're thinking through, when you're thinking through how you build an image, right? How a developer builds an image. Often they craft it themselves, right? They're, with the Advent of containers, then it was like, what do I put in the container, right?
Yeah.
It's like, well, here's grandma's rocker. We'll put that. And it just became a mess. And now I know there's tools emerging that are going to help kind of with that build process. Right?
Totally. So a lot of the customers that we have at Aqua Security will have policies around the base images that their developers are allowed to start from. So maybe they've got a different base image for each different language that they might use. There might be a Python base image and a Node base image and a Java base image. But the security team will have looked at what's contained in those base images, and they'll have some confidence. And making sure that every image you then build has been built on top of one of those approved images, it can give them some confidence.
So what are some of the vulnerabilities that are emerging, right, that come out of this? Like, what are the vulnerabilities that you're trying to address now that are growing in scope and going to take on different forms?
Well, there are new vulnerabilities discovered every day.
Yeah.
And some of them maybe got introduced into a piece of software really recently. Some of them could have been around for years and years.
Yeah.
I'm pretty sure that Heartbleed was in code that was years old. So you never know where an exploit's going to come from. Every time there is an exploit, there's this process around the vendor, the person who wrote that software, having a patch, getting that patch applied to distributions, into packages. It's actually kind of complex because all the different Linux distributions have their own package management, management processes, and they might handle, some of them will take a new update, some of them will backport a patch. So you really want your vulnerability scanner to have knowledge of not just the basic vulnerabilities, but also which distributions have those vulnerabilities in which different levels of each package. And that's something that differentiates different image scanners. So, Aqua has a lot of intelligence from a lot of different sources, plus a research team, putting a lot of work in to make sure that our vulnerability reports don't... The big thing is false positives. You tend to get false positives if you don't have all those sources.
I'd like to read just from this blog post you wrote in March, just quickly. You're a very clear writer, so I wouldn't just do this down further. But you said a container image scanner looks at the software packages included in the image file system and checks it against a very long list of packages with known vulnerabilities.
Yeah.
Right? typically the MVD. There are several free and paid options for vulnerability scanning and container images, so you might rightly ask, what's so special about Aqua offering? Well, let me ask you then, what is so special about Aqua's offering?
Yeah, so it's really the different sources, bringing in information from the NVD, which is the National Vulnerability Database, but on top of that, applying knowledge about the distributions, applying knowledge from upstream vendors. Sometimes the vendors, like the database software, might have their own security disclosures, language-specific disclosures, plus actual manual intervention. We have this, the research team in Aqua have this whole tool around kind of where there's doubt about whether a vulnerability is really there in a package or not, and they'll go and check it. And so we have this huge amount of research going into exactly which packages in which distributions contain which.
Oh my gosh, you must be learning all kinds of things out of that.
Yeah, I mean, there's so much detail in that.
Yeah.
It's really
How
impressive.
are you organizing that data then?
Yeah, they have like internal tools to manage that.
Right.
Yeah.
Right. So what are the other kind of components of it that Aqua looks at it from? Like you look at it from the scanner perspective. We also talked about the runtime perspective.
Yeah, and some of this stuff is just so fascinating to me. I could talk for hours.
Yeah.
So what it really boils down to is knowing what a particular piece of software should be doing. We learn what normal behavior looks like, and then we can spot when something unusual happens, when something anomalous happens, like, for example, accessing a file that shouldn't be accessed, or running as a user ID that shouldn't be run. And particularly if we're talking about microservices, that it's really reasonable to think about what a particular service should be allowed to do. Should it, what network traffic should it be allowed to talk to? Should your microservice, maybe you've got a product search microservice, it has no business contacting a database with user data, for example. And being able to constrain what that containerized code does, so it can't talk to that user database, and it can't, start pinging for different network components that it might be able to, it can't start exploring its own local network. The more you can construct, we talk about shrink wrapping the behavior of a container at runtime, so that we can flag and, either alert or prevent something outside that normal behavior, which is really powerful.
Interesting.
And actually, if we're talking about CICD, you kind of need to build that into, if you're deploying a new version, you might need to relearn what that behavior is, because the new version might have, a change in features that means it's going to behave slightly differently. Maybe it does need to access a different file. So being able to keep those runtime profiles up to date is also important.
So how do you keep the runtime profiles up to date?
Reprofiling them automatically.
Just reprofiling them. And so how are the profiles then getting defined? Like, what are you thinking about in that respect? So
it's very much up to the customer to kind of decide what kind of risks they want to take, and I guess there's the balance between, do you want to be really careful about what you want to let your software do, or suppose that you don't want to cripple your deployment, and so a lot of people will choose to alert if anything goes wrong, just in case it was something that was missed during profiling. But the kind of things you might do, you might say, here's the set of executables that are allowed to run, and I'm going to forbid any other executables from running. So, as an example, it's really bad practice to SSH into a container. Most container images don't have SSH included in them, but if you did have a container image and it had SSH in it, you could have a profile that says SSH is one of the executables. It's not going to be, we're not running that. There's no good reason to run that. And that SSH is a tool that could be extremely dangerous from a hacking perspective.
Yeah, because they can get in anything, right?
Yeah, right.
Yeah. So how do you prevent them getting? I guess the question is like, how do you get them from getting into all the containers?
Yeah, and
you don't want SSH in there for that reason alone.
Yeah, I mean, nobody is ever going to say everything is secure because the risks are coming. It's all a question of risk, and attacks come from new sources every day. I'm going to be talking tomorrow actually about some privilege escalation issues that maybe people don't realize. People don't realize they're running as root half the time. That's what I'm going to be talking about.
Is it because they don't have the observability to some extent?
It could be. Yes, it could be. I think having tooling that lets you know when you are. I mean, actually, that's another thing you can see from the Aqua Security console is containers that shouldn't be running as root but are. That's something else that we can highlight and also give kind of advisories on. Perhaps you want to run this container not as root.
Just thought.
Yeah, and I guess you could hook that kind of audit logging into broader log management or SIEM management systems.
Yeah, I guess it leads a lot of questions about monitoring the components across the environment.
I mean, that whole observability world there's so many aspects to it, and we touched very briefly on all the different projects in the CNCF yesterday, and there's several of them related to observability, tracing, logging. It's a big field.
So what are the projects then related around security that are of interest to you?
Yeah, so there's a couple of new projects that have just joined the CNCF. One of them is the Open Policy Agent, which is a general purpose engine for policies. So I think we'll be looking at that. We're obviously defining policies related to images and runtime. So
you might be able to offer that as an image that you can.
Yeah, it's really early days, I think, for that project, but it's obviously there's some overlap there that we'll be looking at. And the other one that I'm keen that we look at is SPIFFE, which is this secure identities.
Yeah.
We're obviously seeing more service mesh and more like secure connections between containers, which is a very good thing.
Right.
And the way that those containers identify themselves to each other, it'd be really good to have that integrated into Aqua tooling as well, so that there's a common identity.
I've noticed a kind of a more discussions about these communication layers that we're starting to see emerge. Where so you can't have that communication. But for example, I would think in a security context between the containers themselves, right?
Yeah.
Yeah. But then also, how they're kind of, how they're behaving on, on the runtime, for example.
Yeah. So network microsegmentation, another component that we've had in the Aqua platform for a while, which is the idea that containers should only talk to a certain other set of containers.
Right.
Really related to some of the tooling that we see in service meshes, which can control which services can talk to each other. We do it at a container level, so there's a slightly more granularity there. And I think also looking at the configuration of these things is going to be really interesting moving forward. Configuring a service mesh, not something you're going to just take 5 minutes over.
No. Yeah. No, it's starting to get all very confusing for me. There's new concepts emerging all the time, such as operators, right? The operator role. It's been around a long time, right? The whole, the concept of the operator role, but it's taking a much higher profile.
Yeah. There's definitely some things I need to look into more that, like Brandon was talking about this morning.
Right.
Yeah.
Yeah, but I guess going back to kind of continuous integration, continuous delivery, and Kubernetes and security issues that that are being discussed now. there's been this odd relationship between developers and security teams for a long time, right? It's like they check, you always hear it at a conference like this, like they get out the checklist and you won't get that check, and that means forget it, right?
Yeah.
What are the conversations you're having with developers now that are striking to you about security?
I think the interesting conversation there is the shifting left of security concerns, not applying security as an afterthought, but building security in from the get-go. DevOps processes and CICD can actually help with that conversation, because if you do things like, you have a security team that determines what your base container image is going to be, and the developer has to use that. And if they have concerns about that image or they want to change something, then they can have that conversation with the security team early on, because they're continuously shipping, rather than waiting until, the feature is due to be delivered. They can have those security conversations really early in the process.
But what are developers, like at an event like this, when you're talking to developers, what kind of questions are they asking you, about scanning and CICD and the role of security? Actually,
the biggest question that's come up about scanning has been to do with this whole question of false positives. And I think some people have been bitten with scanning tools that just take a single source of information. They scan, they find they have a lot of false positives, and then they're kind of like, well, this isn't giving me anything useful. What's the point of doing this image scanning?
False alert,
exactly.
As they say.
Yeah. And so I think one of the things we want to do with Microscanner is give people a tool that is less prone to I'm not going to say there's never going to be a false positive, but it should be a lot less prevalent than perhaps we've seen with some more straightforward tools that just deal with the NVD.
So what was, what was the technical architecture that you built for that scanner that does distinguish it?
So this is going back to the combining of the intelligence from all these different sources.
Right.
So the microscanner is like a small executable that you can build into your container image. It calls out to we call it the cyber center, which is the repository for all this vulnerability information that we've collected.
That you're collecting from all the scanned images you're doing.
Yeah, well, and from all these databases, these security advisories from the distributions and the vendors and what have you.
Which you guys well know through your own practices over many, many years and how to kind of build that data.
Yeah, and we're constantly updating those sources. Yeah. And then that's exactly the same cyber center that our commercial tool is using, but available for free.
Right.
Yeah.
Well, I just want to, maybe in conclusion, just kind of getting a picture of like, what is your vision for, how we're going to be thinking about, building images and, for Kubernetes.
So I guess one thing that is definitely afoot in the image building world is the need to build images unprivileged. So we've kind of fallen into habits of using tools, no disrespect to Docker, but you shouldn't need to have root privileges to build an image. And I think we're seeing a lot of activity around that. That will make integration into CICD pipeline much easier, because nobody wants their CICD pipe. They don't want their Jenkins deployment having root privileges over their container deployment, their Kubernetes deployment. So removing those privileges, it'll make things a lot more secure, and things are on the up. They're improving.
Nice.
Yeah.
So what are some of the projects that you're looking forward to seeing develop? Like Spiffy, I would expect then. And OPA, I guess.
Yeah, Spiffy, Open Policy Agent, Grapheus. I know there's been some interesting things going on related to Grapheus, and I haven't caught up with them yet. So
we'll have to catch up on Grapheus another time.
Yeah.
But thanks, Liz, for taking the time to talk, and congratulations on a great event here.
Thank you. I'm glad it's going so well.
Yeah.
Great.
We'd like to thank Aqua Security for sponsoring the new Stacks ebook about CI/CD and Kubernetes. You can learn more about Aqua Security at aquasec.com. Listen to more episodes of the New Stack Bakers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.